All right, today is properties of logarithms. I love this section. Maybe you'll like it as much as I do by the time we get to the end. So let's first talk about what you should already know. You should know that the logarithm of base b of y equals x is interchangeable with b to the x equals y, okay? Lots of teachers, they teach it different ways. I do the circle here, and then I undo it with the circle. So if you see me do that, that's just my way of working stuff out. Let's talk about the goal for today. Well, we have two goals, actually. We have to be able to use properties of logarithms to evaluate expressions. All right, that's one goal. And the other one is to expand logarithms and make them nice and big and large, and later on you'll condense them. But today we're going to expand. So those are two goals today. But first let's talk about the properties. So let b, u, and v be positive numbers such that b is not equal to 1. First let's talk about the product property. And product should make you think of multiplication, right? So if I have the logarithm base b of u times v, all right, those are multiplying. To expand that back out, multiplication will turn into addition. So we'll still have log base b, right? We're going to have the old plus sign there too. But now this is going to have a u on it, and that's going to have a v on it, okay? So if they're multiplying, you want to turn it into the addition of separate logarithms. Okay, quotient means division. So if we have logarithm base b of u over v, you're going to take this division and you turn it into subtraction. Now you're probably thinking, like, this is really weird, like multiplication and addition. Well, think about what you used to do. X to the third times x to the eighth. What do you do with those exponents? Oh, you add them. So if you multiply two things, you're going to add the exponent. So that's where it's coming from. So let's go back to it. So if it's dividing, you're going to subtract. So we'll still have log base b. I'll put my minus here. Log base b, but it's going to be top minus bottom. Okay, so you're going to subtract them. So if they're dividing, you're going to turn it into subtraction. You know this already, right? Remember when we used to have x to the 11th over x to the 8th? What do we do with the exponents? Subtract. So when you divide, you subtract, right? So I just want to kind of bring it back to what we've done before. And the power property. The power property, if we have log base b of u to the n, what you can do is you can take that little power and you pull it down to the front so it's now a coefficient. So n log base b of u. Okay, so the power becomes a coefficient. That's how I do it. These are the only three things we're going to really use today. That's it. It's going to be super awesome, super easy. At least I love this section. So let's go ahead and get to these ones here. So they're telling us that log base 9 of 5 is this, and log base 9 of 11 is this, and they want us to approximate this. Well, okay. Notice there's only one log here, so don't just put this in and put that in. You got to make this a log base 9 of 5 and a log base 9 of 11. Well, it's dividing. So if it's dividing, you're going to turn it into subtraction. So top minus bottom. All right? And we know that log base 9 of 5 is 0.732 minus log base 9 of 11 is 1.091. So 0.732 minus 1.091 is going to give us negative 0.359. Done with that. Beautiful. Let's look at the next one. Ooh, 55. What are they talking about here? I only got log base 9 of 5 and log base 9 of 11. Well, can't you change 55 into 5 times 11? So we can say log base 9 of 5 times 11 here. Don't leave it like that. You can't substitute anything in yet because I don't have log base 9 of 5 separate from log base 9 of 11. But if they're multiplying, you can turn it into addition. So we have this plus log base 9 of 11. So this one is 0.732 plus 1.091. And when we add those together, I'm just going to do that like this, which probably is taking me longer than just rewriting it, but whatever. 1.823. All done with that. Let's look at C. 25. Okay, 11 is not involved in that at all. Like, I don't see how 11 could be. But isn't 25 5 squared? So we've got log base 9 of 5 squared. You take your 2 and you can pull it down to the front. And you know that log base 9 of 5 is 0.732. So we've got 2 times 0.732. So 2 times 0.732. And we have 1.464. Ta-da! All right, so we're done with those. We had to use a lot of properties there too, right? We used all 3. So let's do example 2. Use property of logarithms to evaluate the expression. Okay, well they're multiplying, so we turn that into addition. So log base 2 of 8 plus log base 2 of 16. Now what are you gonna do from there? Well, let's think about 8. If we break up 8 with the factor tree, we'll get that 8 is 2 to the 3rd power. And let's think about 16. If we break up 16 with the factor tree, we'll get that 16 is 2 to the 4th power. Now, I didn't draw the factor trees out. If you need to do that, do that. Feel free. I'm just going to skip that part. And then we can take these exponents and we can pull them down here as a coefficient. Now, log base 2 of 2, what is that? Well, let's think about it here. If I have log base 2 of 2, and I don't know what it equals, so if I don't know what it equals, I'm going to say that it equals x, right? And then we do our circle thing. 2 to the what gives me 2? Well, 2 to the 1st, right? So log base 2 of 2 becomes a 1. So we've got 3 times 1 plus 4 times 1. And when you finish that up, you get 7. Okay? This next one, natural log. Now, do you remember natural log? Natural log is just the logarithm of e. Okay, so natural log is literally this part right here. Well, we can bring down our 5, right? And then log base e of e, again, just like we had log base 2 of 2, we can make that a 1, and we just get 5. All right, so using those properties. Let's move on down to the next page here. Remember, if I'm going too fast, pause me. Honestly, I would just watch the video the first time and then do the notes the second time. That's how I do it. So, whatever works for you. Expand. All right, so we're going to make this thing way, way bigger. So the first thing that I see students do is they want to pull this down. Don't do that. Don't do that. Because if you pull that down, you're telling me that 6 is also an exponent on that 2. And it's not, right? It's just an exponent on the x. So the first thing I would do is see these 2 guys right here? Those 2 are multiplying. So if they're multiplying, you're going to turn them into addition. So log base 5 of 2 plus log base 5 of x to the 6th, like that. Now you can pull that 6 down. So log base 5 of 2 plus 6 log base 5 of x. There's nothing else you can do here. You're all good. It's expanded out. It's as far as it can go. Okay? Let's look at B. Don't pull that 2 out or anything, so 2's only on the x, and we don't have the x isolated yet. But we do have division, and division means you can subtract. So log base 7 of y minus log base 7 of 3x to the 2nd, okay? So this you can't do anything with right here. But over here, that 2, that exponent of 2 is only on the x. So you cannot bring it out yet. Okay, but these 2 are multiplying. So, and notice what I'm doing. Do you see I'm putting parentheses there? Why is that? Why is that? Because we're subtracting this whole shebang, the whole thing. So whatever I do with this whole thing, that negative goes on the whole thing. So I have to make sure that if I'm going to distribute it out, that I have the parentheses on there. Now I can pull this 2 up. So log base 7 of 3, and then here we go. 2 becomes the coefficient, and we have this. And then don't forget at the end to distribute your negative side. Now, notice it totally looks like we have expanded something. It's a lot larger than what it started as. All right? There you go. All right? Let's look at C. So log base 3 of 12 to the 5, oh my goodness, okay. So first things first, let's bust those 2 up because they're multiplying. So log base 3 of 12 to the 5/6 plus log base 3 of x to the 9th. Okay, well, I don't know if 12 to the 5 6 will give us anything. I like to always try it. Oh, need a parenthesis. No, it's disgusting. Okay, so we'll just bring the 5 6 up front. Okay, we have our 12 here, plus 9 log base 3 of x. Now, you might think, ooh, I am all done, but you are not all done, because 12 right there, it busts up. It can bust up into 3 times 4, right? So, 5, 6, log base 3 of 3 times 4, plus 9 log base 3 of x. Okay, so then with the 3 times 4, couldn't I technically bust that up into addition again? I could. So 5, 6, and then let's just get to the point here with this one. This 4 right here, can I just say the 4 is 2 squared? Right there? So I have log base 3 of 3 plus log base 3 of 2 to the 2nd. Notice I got parentheses on it. Log base 3 to the x. All right? And what I want you to do is I want you to finish that one up and bring it to class tomorrow. Just finish it up here on the side and go ahead and bring it to class tomorrow, okay? I want to see if you can work this out all the way, and I'll finish this one in class for sure. So let's talk about D. This one looks pretty easy to expand. There's multiplication, multiplication, all the way across. So we're going to have a couple of things we'll break apart. We've got the 6, plus we've got the log of x to the 3rd, plus we have a log of y, plus we have a log of z. All right, and then the only thing we have to do is pull down that exponent. Now 6 does break up into 3 times 2, so let's go ahead and take care of that right now. So there's that, and then we'll bring this down. And some teachers don't make you simplify as far. I'm all about simplifying all the way. So we have this, and then last not least, there's 2 plus log base 3 plus 3 log x. Doesn't that look crazy? Like, seriously, show your parents what you did, and they'll be like, whoa. That's why I like these, because you look ultra smart when you're all done with it, right? All right, so there's that one. That one's not too bad. Just remember to break up the 6 and remember to pull that exponent down, okay? Ooh, E has a little square root on it, but that's not going to bother us at all because we know now that we can write this as a fractional exponent. And then what do we do with that? The whole thing, it's on the whole 4x, right? So the 1/2 can come down up front here. And we have this. But 4 times x, we need to bust that up. And then just remember that 1/2 is times all of that. All of that. And are we done? What's that for? Isn't that 4 right there? A 2 squared? It is. Okay. Okay, now I have to pull that 2, that square, right up front. So now I have 1/2, 2, log base 2 of 2 plus log 2 of x. Woo-wee! Now, multiply your 1/2 times these coefficients, and you'll have log base 2 of 2 plus 5 log base 2 of x. Woo, boy. Oh, wait, I'm not done. What's log base 2 of 2? It's 1. It's 1. That was a good one right there. That was a really good one. I will watch that one a couple of times, for sure. And what I want you guys to do, if you could try out F, G, and H before you get to class, you have to have those done. I want you to try them. I want to see if you get the right answer. And just bring those to class, and I will see you then. Have a good one.